Next we will find what is the final velocity after time t. So we will use the vector concept. V vector is equal to u vector plus a vector into t. We can use this equation when acceleration is constant, or uniform. Acceleration is constant or uniform. So v vector is equal to u vector, which is u cos theta I cap plus u sin theta into j cap, and acceleration vector is equal to minus g j cap, because the direction of acceleration is downward, g into t. So acceleration into t means minus g j cap into t. So now I together, j together. So this is u cos theta into I cap plus u sin theta minus gt in the bracket, and j cap is common. So this is the velocity vector. So the velocity vector has two components, which is vx, the x component, and the vy, which is the y component. So the x component of final velocity is u cos theta, and the y component of final velocity is u sin theta minus gt. If we find the magnitude of this velocity, we will get speed after time t. So that will be equal to the magnitude of velocity vector. So the velocity vector magnitude, now we know that if vector is ai cap plus bj cap, the formula is square root of a square plus b square. So we will use this formula to find the speed after time t. So that will be equal to magnitude of v vector, which is u cos theta I cap plus u sin theta minus gt j cap. So that is equal to square root of u cos theta whole square plus u sin theta minus gt whole square. We can also find it as u square cos square theta plus, now we are using a minus b whole square, so that will be equal to u square sin square theta plus g square t square minus 2u sin theta into gt. U square cos square theta plus u square sin square theta will become u square. So this is our answer, square root of u square plus g square t square minus 2u sin theta into gt. So this is the instantaneous speed after time t. Now let's draw the projectile path. So this is the projectile path, this is the ground level. When the particle is going up, means during the ascent, we are observing that the angle it will make with the horizontal, that is angle of inclination, is decreasing. If initial angle is theta, after some time the angle becomes alpha. If you see, this is the ground level, or the ground is horizontal. So this is the initial velocity. After some time, the velocity is like this. So what you are observing, initially it is making more angle, greater angle it is making initially with horizontal. After some time it is making a smaller angle with horizontal. And at topmost point it is making zero angle with horizontal. So initial angle of projection is theta or inclination. After some time it is alpha, and topmost point it is 0. So how to find this alpha? What is angle of inclination after time t during ascent? During ascent, what is the angle? Alpha. The angle made by velocity vector with horizontal. So we will write this velocity vector in vector form. We have found this v vector is equal to u cos theta I cap plus u sin theta minus gt j cap. So how to find what is the angle made by this vector with horizontal? If we draw this vector, it will be like this. This is the v vector. So this is the horizontal component, which is u cos theta, and this is the vertical component, which is u sin theta minus gt, and the angle made by this vector with horizontal is alpha. So we can say that the tan alpha is equal to opposite by adjacent. Suppose it is u sin theta minus gt, adjacent is u cos theta. So tan alpha is equal to u sin theta by u cos theta minus gt by u cos theta. So we have tan alpha is equal to tan theta minus gt by u cos theta. This is the formula for tan alpha. Remember, we can use this formula only during ascent. So let's solve one question based on this formula. So I'm writing this formula again. So tan alpha is equal to tan theta minus gt divided by u cos theta. Now the question based on this formula is, a ball is thrown with velocity 2 meter per second at an angle 53 degree with horizontal, means the angle of projection is 53 degree. Find time after which velocity vector makes 37 degree with horizontal. So let's draw the diagram first. So initially the angle is 53 degree. Initial angle is 53 degree. After some time the angle is 37 degree. So how much time, after what time the angle becomes 37 degree? So in this question, alpha is given as 37 degree, theta is given as 53 degree. So we will use the formula tan theta is equal to, sorry, tan alpha is equal to tan theta minus gt by u cos theta. So we have 1037 is equal to 1053 minus GT, G value I am taking 10, U is given 2, then cos theta, so that means cos 53. Now substitute the values of 1037, 1053. We can recall how to find these values. If we have a right angled triangle like this, so adjacent to 5 and 3 are sides 5 and 3, opposite to 53 is 4. So we can say 1037 is equal to 3 by 4, 1053 is 4 by 5, and sine 37 is 3 by 5, cos 37 is 4 by 5, sine 53 is 4 by 5, and cos 53 is 3 by 5. So let's solve this equation. So 3 by 4 is equal to 4 by 3 minus 5 into t divided by cos 53. Cos 53 is 3 by 5. So 4 by 3 minus 3 by 4 is equal to 5 into 5 into t by 3. So 25 by 3 into t is equal to 16 minus 9 by 12. So 25t is equal to 7 by 4. So t is equal to 7 by 100 seconds. So t is equal to 0.07 seconds.